In this video, we're going to be going over trigonometric graphs and some of the definitions in them. So this first graph that we're looking at is just a plain sine graph. It's just f of t equals sine t. And with that, you notice that each of the marks noted is a full pi. So it's pi, 2 pi, 3 pi, 4 pi. These pi's coincide with the unit circle that was covered in the previous video. Because this is a plain sine graph, you just simply input at every pi, and this would be pi over 2, this other marker. And so you'd see that sine pi over 2 equals 1, which is why this is a peak at 1. And sine pi equals 0, which is why there is a intersection with the t-axis at pi and all the full pi terms. The definition for the distance between 0 and the peak of the graph is the amplitude. And down here we have a diagram just showing more clearly what the amplitude is. So it's just the peak, you go over and you see how high it is compared to the center of the curve, because it's going to be the same on each side. So the amplitude, which is spelled like this, is going to be the absolute value of this A. So it could be, you could be measuring it from either the negative or the positive. The other term that we're going to be exploring in this sine graph is the period. And so the period is the amount of t time on the t-axis between 2 points. So that could be between a peak and a peak, a valley, or a 0 and the next 0. So you're going to have one downward curve, so a U, and one upward curve in each period. And that again is right here, so you can track and discount how many peaks and valleys are in each to figure out how many periods there are. Now we're going to be looking at some modified sine graphs. This graph is g of t equals 3 sine t. And you notice that the amplitude of this graph is 3 and not 1. The graph looks about 3 times higher. It's stretched out right there. And with this one right here, you notice that instead of the previous sine graph where each period was 2 pi, being from 0 to the double 0, it is from 0 to 2 pi. In this one, it is from 0 to pi. So the period is actually half of the initial period, which is what we call the standard period. And for different trigonometric graphs, you're going to have different standard periods, which is what we're calling the term of just a unmodified, there's no numbers, it's either sine t, cosine t, tangent t, or cotangent t. And for sine and cosine, your standard period is going to be 2 pi, like the initial graph we saw. For tangent and cotangent, your standard period is going to just be pi. So it's going to do a full peak-to-peak cycle in pi time. And you can find the modified period, for example, for this graph, which is sine 2t. The modified period, it would be the standard period divided by the absolute value of this b value, which b is just a placeholder for whatever value is multiplied by the t. So this period, which is simplified by this curly w, is going to be equal to, since it's a sine graph, it's going to be equal to 2 pi divided by this 2 value, which is the absolute value of 2. And that equals a period of pi, which is why you see from end to end of a period, it's going to take pi time to do that. So that's not the only way that you can transform a function. We're going to be looking at an example for this problem, which is f of t equals sine t plus pi over 3. And so when you see that, you're going to see that this actually shifts the sine wave over to the left, because so we established earlier that sine of 0 is your zeros, sine of pi is a 0, etc., etc. So setting t plus pi over 3 equal to 0, you notice that t has to equal negative pi over 3 to get that 0 value. And so that is why the graph shifts negative, even though there is a positive value here. And so if you had a value that was, say, sine t minus pi over 3, that graph would actually shift to the right. So your normal graph will look like this, and your new one is going to be like this. It's going to be over to the left by pi over 3 amount. So also, a different way that it can be shifted is if the number is added or subtracted outside of the parentheses. So and that shifts the graph up and down. So you can see if sine of t plus, if it's f of t equals sine of t plus 1 on the outside, if you plug in the values that we were using before of sine 0 plus 1, well, your f value is going to equal 1. So it'll shift up by 1. And since this is a unamplified value, if the sine is pi over 2 plus 1, so that will be that, the value will actually equal 2. So even though your amplitude is still 1, your peak is going to look like it's at 2. But it's not at 2 because where the 0 is still 2 minus 1 is 1. That's how tall your amplitude truly is. And so if the value was sine of t minus 1, this would be the original, and your new graph would actually be subtracted by 1. And so your peaks would be happening at 0, because sine pi over 2 would be 1 minus 1 instead of 1 plus 1. So another thing with phase shifts is which is the horizontal shift, because you're shifting where the phases occur, which is like where the periods are. You can see that in this example, you want to make sure the x value is always alone. And so how you can do that is find how to separate this. I'll pull it out here. So over here, it's pi x plus pi over 2. There is a pi value in each of these terms, so what you can do is pull that out. So it's going to be pi x plus 1/2. And so looking at that, your phase shift is going to be this 1/2 value. An easy way to get this done every way, even if there is not the same values in each of the forms, like next to the x and not next to the x, say it's 2x plus 5. You need to get this 2 away. So how you can do that is have it be 2 on the outside, x plus 5 divided by 2. And this 5 divided by 2 is going to be your phase shift. And it's still functionally the exact same formula. So the general form of a trig function is going to be capital F of t equals a lowercase f parentheses b parentheses t plus c parentheses and close both parentheses plus d, where f of t is a basic trig function that we talked about earlier, such as cosine t, sine t, tan t, or cotan t. And all of the values that we described earlier, all the different definitions of different parts of the trigonometric graph, you're going to have the absolute value of A is your amplitude. So you don't have to actually look at the graph to find any of the values we talked about earlier. The standard period, which we talked about earlier, being for cosine and sine being 2 pi, and for tan and cotan being pi, that's standard period, SP, divided by the absolute value of B, this value here, is your period of your graph. Your phase shift, which is the left and right shifting, is going to be C over B, which we just talked about earlier. And finally, the value of D in this general form is your vertical shift. And that is up and down. So that is a review of the trigonometric graphs and how to find these values just based on the equation you're given. And you can use these different amplitude, period, phase shift, and vertical shift. Knowing these, you will be able to easily construct your trigonometric graph. Have a good day.